So, can you hear me? Yeah, great, thanks. So I'm going to tell you about one study that I'm working on right now in my postdoc with Katarina and Begus, and we're looking at error monitoring and adaptive information seeking in 12-month-old infants. So we know that infants have been shown to be able to adapt and optimize their own information uptake. So they attend to stimuli with optimal levels of predictability. They also attend to events that violate their expectations, and they can selectively request information from knowledgeable others. And so these behaviors are consistent with theoretical accounts of information seeking and learning that is intrinsically motivated. And so according to recent accounts such as Oudillet and Kaplan's learning progress theory, individuals should direct their attention and choose activities that afford the fastest learning progress. And so in other words, activities that offer the fastest reduction in errors. So an obvious way of ensuring that an individual error rate will decline is for the individual to gather information, both following an error, but also prospectively in order to avoid future errors. So in order to do that, we also need a mechanism that signals when a prediction or a decision error is detected. So the question is, how are errors monitored? So the human brain actually monitors and signals when it detects an error. And using EEG, there's a lot of research that showed that there's a prototypical neural response when participants detect or commit an error. And this is called the error-related negativity, or the ERN. And the strength of this ERN has been shown to predict whether individuals will adapt and strategically change their behavior in learning tasks. By the age of 12 months, infants actually already show typical ERN neural responses when they make an error, suggesting that they internally monitor their own mistakes. And here, what we wanted to do is to make use of this neural signature of error monitoring and investigate how it relates to infants' information seeking in a gaze-contingent interactive paradigm. So we use contingent eye tracking. This means that infants can interact with the display and control what they see and for how long. And so this enables us to study active information search. At the same time, we record neural responses with EEG as the infants progress through the task. And so what happens first is that we teach them that they can interact with the screen by using their eyes. So they're shown some cards on a screen, and if they fixate on one of them, the card will flip and show them the image that is on the other side. If they look away from the card, it flips back, and then they can reveal another card by looking at it. So this is what it looks like. Here you have a video. I don't have sound. We can fix that, but basically you can see the infant's gaze as a green dot, and if you follow it, you can see that the infant is flipping cards and just exploring around. Hopefully you can see that. Now the infant's looking away, and then they come back and they flip different cards. So we've given them plenty of experience with this, and then we move to the second part of the training, which is where we teach them that the game is actually to find two cards with a matching image. So in other words, the game that they're playing is a match to sample task. And so that's pretty similar to the children's game memory. And this is what it looks like once they reach our test trials. So they're shown two images with the image faced up at the bottom of the screen, and then one image at the top, which is face down. And they can explore the bottom two images for the time that they want. Once they gaze at the top card, it will flip the whole set of cards. And now they can look back at either of the bottom options to make a pair. So if they look at the matching card, then they get a reward. If they look at the card that was different, then the images just fade out. So again, here you can see the infant's gaze on the screen, and this is what it looks like in a trial when they respond correctly and they find the match. So first, they just explore the bottom two cards. Now they flip the top card, and then they flip the correct one. So they get a little animation that you cannot really hear, but it goes like, woohoo! And then there's a little clapping sound in the background to kind of cue them that this was a correct trial. In the trials, when they gaze at the different card, so they are incorrect. This is what it looks like. So they explore again the bottom cards for how long they want. They flip the top card, and then they flip the different ones, so the cards are just slowly fading out without a positive feedback. Okay, so in order to investigate our question, which is whether infants gather information adaptively, we created different difficulty levels, and so they have increasingly similar items on them. So in the easy trials, the infants are shown items that are very different, they're from different categories, and they're fairly easy to encode. Finding the match is not very difficult in this level. Then in the medium trials, they see images from the same category, which is here vehicles. In hard trials, they see the same category and subcategory, but the colors are different. So here they see 2 cats from the animal category, but one is red and one is black. And then in the hardest level, they see 2 items of the same subcategory, but also the same color. And so here we really made it quite challenging for the infants to find the match. So in this experiment, the infants do not see the trials in a randomized order. We actually made it adaptive, such that they only progress up the difficulty levels if they get a couple of trials correctly in a row, and then they also regress if they get a couple of incorrect trials in a row. And so that's for us to ensure that we record both correct and incorrect trials from each infant, and that's crucial for our EEG measure of the ERN. But it also allows us to see whether the infants seek information, more information, when the match will be more difficult to find in the difficult trials. So this might look like a fairly complex task for 12-month-olds to do, but we actually know from the literature that they are able at this age to learn the match to sample rule, to control and interact with a gaze contingent display using their eyes, and that they also exhibit the neural signature of error monitoring. So we're hoping that we can pull all of that together in this complex design and they can still do it. So on to our results. All these analyses have been pre-registered, and they're actually sort of fresh out of the oven. We just finished them this week. So we're very much looking forward to hearing your comments and suggestions on this. And so here, I will talk to you about the eye tracking data first. So we tested 124 infants with this paradigm, and here we have 83 of them included. So we've excluded those who had less than 10 trials, as well as those who had less than 5 medium or higher level trials, because we consider that they cannot perform the task. And our question here is whether infants show strategic information gathering. And that would predict that there should be an increasing exploration with increasing difficulty. Alternatively, if their visual exploration is driven by other factors, such as saliency, we might expect that there's a decreasing exploration with increasing similarity, so in more difficult levels. And so here we're interested in the phase of the trial when the infants are exploring the 2 bottom cards before they gaze at the top card to flip it. And the first measure that we looked at is just how much time infants spend exploring and looking at those 2 bottom cards. And here it looks indeed like they do explore the images for longer as the difficulty gets higher. We can see the same pattern in other measures, such as the number of fixations that they make, or the number of switches that they make between the 2 cards, so they also increase as the difficulty increases. And so here we have good evidence that the babies are doing something different at the different difficulty levels, which suggests that they do adapt their information search depending on the difficulty of the task. But does this adaptation of their exploration actually relate to better performance? So again, we looked at exploration time in the same time period, but this time comparing the trials when they were correct and the trials when they were incorrect. And so interestingly, this actually showed an effect contrary to the prediction that we made. So here, the trials in which infants did not find the match were actually the ones with the longer exploration times. And so based on this, we cannot say that infants' adaptive information gathering leads to a reduction in errors. And to be fairly honest, we don't really know at the moment exactly how to interpret this result. But something I can add about this is that, interestingly, this difference is absent in our other measures. So it does not translate to more fixations or more switches between AOIs, which might suggest maybe that there's a more passive viewing of images in these incorrect trials. This is something that we want to explore more in the future. Okay, but do infants in fact know when they've made a mistake? To answer this, we look at the EEG data and we analyze whether the infant's neural activity reflects a detection of their errors post-fixation on a card and prior to visual feedback. Here we have 48 infants included. This is because we need a minimum of 7 clean trials in the correct condition and 7 clean trials in the incorrect condition, so it's a bit more stringent. And we're interested in a slightly different phase of the trials, which is when the infants have explored the card, they've flipped the top card, and now they're gazing back at either of the cards to pick a match. So here, if we see an ERN response before the visual feedback is provided, this would suggest that infants do detect when they've made an incorrect choice themselves. We based this analysis on a study from Louise Goupil and Sid Quider, which did find that at 12 months, infants do show an ERN response after making an error themselves, so gazing at an incorrect location. And so we looked at the same cluster of electrodes than in this study, so frontal central electrodes. And this is what it looks like for correct trials in blue and incorrect trials in red. All the electrodes are overlapped on the same plot, so every line is a different electrode. Here we're interested in the time window between the time when the infant fixated on a bottom card and the time when the bottom card was flipped, so they don't have any feedback at the moment. The data is baseline with a window prior to them making a saccade, and then we expect the ERN to be in the period of 300 to 500 milliseconds based on this study. So we did a peak analysis of this window, so we took the maximum amplitude for the average of all electrodes per participant in this window, and then we compared the correct and the incorrect trials. And so here our results are a bit inconclusive. So on a group level, the effects do not seem to reach significance. But as I said, this is very new data, and we're still looking into refining our analysis pipeline, so something to keep looking at for a bit. And also, I just want to add that here, our data is averaged over all the difficulty levels together, and we're also pulling all the infants together regardless of their actual performance, so whether they actually learn to do the matching over the task. And so we know that the ERN requires them to understand the task, so to know what is a correct trial or an incorrect trial for it to show in their brain activity. So what we would like to do next is, based on the eye tracking data, to try and distinguish babies who have learned the rule and those who haven't. So this is planned analysis for later. We would like to cluster the babies depending on their ability to match. We'd love to hear your thoughts about this if you have any. And then we're also interested in the temporal dynamics of infants' behavior. So here we would like to know whether infants optimize their performance and their learning, which is a process that actually happens over time. So if we're averaging a cross-trial, we're actually masking a lot of the information that we're interested in. And especially right now we're looking at their exploration preceding an error, but if they're learning something from it, it would also be very interesting to look at their exploration following an error that they've made. So something we're also wondering is whether infants' response to their errors influences how they gather information, and so linking their ERN responses to their gaze patterns on an individual level. So we know that individuals differ in how tolerant they are of their own mistakes, which is reflected in their ERN. And so here we're wondering, for example, if infants who are highly averse to errors might be obtaining more information prior to making a decision so they can avoid making a mistake. And so we also know that the magnitude of the ERN response has been shown to correlate with individuals' levels of anxiety or their risk-taking tendencies. And so this could potentially be linked to how they gather information, indeed. We're also interested in whether this error response is in turn shaped by their interaction with their caregivers and their social environment. So our conclusions on this study for now. So we've shown that infants seem to adapt their information gathering in relation to different learning contexts. But this, however, does not seem to lead to better performance. But we would very much like to look at the temporal dynamics to understand this effect a little better. And we've also seen that some infants seem to detect their own errors prior to receiving feedback about the decision. So as a bigger picture, we're actually looking at this as one mechanism for curiosity and information seeking in infants, but we are actually looking at different possible mechanisms in a larger longitudinal study. And so we follow the same infants at 12, 18, and 24 months, and they go through a battery of tests. So one of them is the task that I just presented you, which is looking at error monitoring as a core ability for curiosity linked to influential models of curiosity, such as the learning progress theory. But we're also looking at the rewarding aspect of obtaining information, the importance of social interactions with their caregivers for information seeking, error monitoring, and learning. And then we're also looking at how the onset of self-representation might interact with the metacognitive processes that support learning and exploration, and especially at the 18-month-old age point. So that big project, what we actually aim to do is to uncover individual profiles for how different information-seeking mechanisms might contribute to infants' learning and might lead to individual differences in how they explore their environment. So thank you so much for listening to me. I would also like to thank Katarina for giving me the opportunity to work on this very interesting project, Dimitrios for helping us in a lot of steps along the way, our students, the families who joined the study, and our funder and institutions. Thank you.
Thank you very much, Cécile. Questions?
Hi, thank you for the talk. I was wondering, in this eye tracking paradigm at test, when infants are exploring these two stimuli at the bottom, they kind of don't have a chance anymore to explore this third item on the top, right? Because as soon as they fixate, as far as I understand, then the card is revealed. So there's no possibility to get back to the bottom two items to explore more. So I have the feeling there's also an inhibition component here that the infants need to engage in to kind of give enough time to explore these both stimuli. So I was wondering what your thoughts are there. So is there maybe, like, could that be problematic that they're not giving the opportunity to actually realize that that's a kind of like a flipped card, the third option, which is on the screen, which might potentially be still kind of crucial and necessary to first find out and to, you know, look at it.
Yeah, so that card is totally crucial. And so that's why we make them explore before, actually. So what we want to look at is how they prospectively gather information. So whether they have some kind of awareness that this is difficult and they're going to need to get more information or more precise information in the difficult trials. And we know that infants are sensitive to errors, but what we don't really know is whether they do this in a reflective way. So this was one way for us to try and look at that. I do agree that there's most definitely an inhibition component in there. And we do have, for example, a temperament questionnaire, so we can totally look at whether this plays a role in there, and we can try and also control for that if we don't think that this is the key function that is needed for this. But yeah, I wouldn't think it's problematic. I think there is an inhibition component anyway when you're trying to acquire information. If you think about, for example, auditory information, you can only gather it once, so you do need to be able to kind of filter it out in a way, and you also cannot go back to it, same as now with this visual information. So.
Mm-hmm. But they're learning that these cards are flipping when they fixate on it only in that first practice where all the cards are basically, you know, like not revealed, right? So
no, so they have more familiarization trials. I haven't gone through that because I had a lot of things to try and put in there. Right. But so yeah, they do 2 trials of 8 cards on the screen that they just flip around to learn the flipping aspect of the task. And then they have 4 trials when they learn the matching aspect of the tasks. Right. And so there, actually, when they flip the top card, they still cannot see the 2 bottom cards, but once they pick an option, both of the bottom options flip, so they can still try and compare what they were doing. They also get 2 chances in the first 2 trials, so they can try and kind of, adapt what they're doing. And,
Thanks.
Thank you.
Hi. I was just wondering if you have any idea or speculation about what would happen if you give them a trial type that is too difficult. So if you just give them identical or like really almost identical objects after training them with this task, do you think they would try to explore even more, or is there a threshold where they just kind of would give up and look away or not be interested anymore, like a Goldilocks type thing?
Yeah, so that's a great question. I think we're already doing that actually. So when we show them 2 items of the same color and same category, they really struggle there, especially at 12 months. And I haven't actually looked at the numbers, but from the testing experience, I have a feeling that they do drop out. So it is very annoying for them to just not be able to do it. But we have this adaptive design where they go back down if they just cannot do it for a few trials in a row. So I think we actually got to kind of a nice level of getting to this sweet spot, kind of Goldilocks spot, where they can do it a little bit and they're right at this level that is challenging enough. But yeah. And so, yeah, one thing I want to say also about this is that these infants actually stay for 15 minutes, sometimes 20 minutes at 12 months. And so I feel like also this interactive part of the screen, the gaze contingent paradigm, but also the adaptive design probably helps a lot with getting at this nice level. This is not why we did it, but it's a great consequence of it.
Unfortunately, we don't have time for more questions, but let's thank our speakers again.
Thank you.